For decades, E. coli has had a huge impact on public health, as well as being financially draining on the cattle industry. Things may be changing soon. Kansas State University recently announced it had a new test to detect E. coli quicker and with more accuracy. We went to Manhattan, Kansas to find out more about this new test.
E. coli 0157 for the last 20 years has been a very, very important issue for the beef industry. We've had a lot of effort at both the post-harvest level and the pre-harvest level to try to both develop better methods of detecting E. coli 0157 and better methods of mitigating against it. In other words, developing the intervention strategies for reducing the risk of that organism showing up in a meat product that the consumer actually consumes.
That goal Dr. Odie referred to has been met. A team of researchers at Kansas State recently unveiled a new test for detecting E. coli.
This test is a molecular diagnostic test, which means we target genes that are characteristic of this organism. And this particular test targets 4 genes. And that's what makes it somewhat unique and novel, and also makes it more specific. And based on our experiments, it is more sensitive also.
Dr. Nagaraja explained how this new test compares with previous ways to detect E. coli.
One of the traditional methods of detecting E. coli 0157 in a sample would be to add the sample to a culture medium that would allow the growth of the bacteria, and then we isolate those bacteria and then confirm that it is E. coli 0157. Typically, this could take up to 5 days for confirmation whether the sample is positive or not. The new method, in fact, this is called real time, because we could detect the positive sample as the reaction is happening in a sample, and we could confirm a sample is positive or not within 1 hour.
In addition to quickly detecting the presence of E. coli, this new test also determines the concentration of bacteria in the sample.
When cattle shed E. coli 0157 in their feces, majority of them shed at a very low concentration. But there is a small subset of population, typically about 10 to 15% of the positive ones, that shed at a very high level. And this we call as super shedders. And these are the ones that we know are responsible for the spread of the pathogen within a herd, within a feedlot, and also responsible for hide contamination at the packing plant, and then the transfer of bacteria from the hide onto the carcass surface. So the goal would be, if you can detect these super shedders and then target them for intervention, that we may have a significant impact in reducing the carcass contamination.
I think the research of Dr. Nagaraja and his team in developing this test, it's a test that is much more rapid, uses a technology that develops the answer to the question much more quickly. It should also be automatable, and it should allow us to do some things that we have not been able to do before, simply because we can get the answer to the question as to whether or not the organism is there much more quickly. The interests of the industry and public health are actually identical here. The industry is as interested as public health officials are in reducing the risk of the organism being in a product.
Consumers and the beef industry will reap the benefits of having an earlier, more accurate, and potentially automated test for E. coli. Reporting from Kansas State University, I'm Janelle Ost for This Week in Agribusiness.